music production for everybody to use. So yes, let's get into this. So why automatic drum transcription in this sense? So Excellent Audio are developing drum plugins, and they want a drag and drop feature to, let's say I have a cool drum kit that sounds very cool, but I want to drag and drop it in, get the notes out, change the music into something else, other samples, change the groove, something like that. And it is time consuming to write it out yourself. So we want to automate this in a sense. Some potential for new features, and the aim is an interpretable, fast, efficient, and hopefully accurate model that creates real value here for them. So the process usually goes like this when you start researching about this, is that the automatic drum transcription is often that you get your data, you read into some Fourier transform, so frequencies over time, so you get kind of an image, a matrix, if you will, and you try to find these onsets, because what's interesting here, you want to find when these drum hits actually hit. And then we later on classify them to the correct instrument and get out these velocity, how hard you hit, and then the annotation. Very niche this, but I love it. And so the model chosen here is a very fast method that's called non-negative matrix factorization. It's been around for quite a long time. It's well used in many different industries. And in this case, we have this matrix over there that we try to divide into different matrices with a thumbnail, or like a template, if you will, for each instrument type and when it hits. So we also added some deconvolution factor to this to remove the temporal factors. As you can see, it's like a hit, and then the hit continues through time, of course, but we're only interested in when it hits and what hits. So reducing the temporal information there. And also adding a sigmoidal constraint so that we kind of try to push it up to be either 0 or 1. Is it hitting, is it not hitting? So that's what we can see here. So the proposed solution here is that I got some data, pre-processed it into these Fourier transforms, and I balanced this unsupervised with a supervised classification model in the end for these different instrument types. Since it's unsupervised, we need to know what type it is in the end. So a hybrid sigmoidal non-negative matrix factor deconvolution is what we called it. Very long word, but yeah, and the CNN pipeline on top of that is a classification in the end. Yeah, with the outputs as the MIDI over there to the right-hand side. Yes, and one of the terms was to be deployable in CPU, because you want to do this in a creative workflow. So that was the aim for this, to make it fast, interpretable, maybe some creative things can come out of it. So yeah, this is like the how we went about this. Did some template initialization for like a clustering way of giving some templates over what instrument is what, and then we can go from there in this unsupervised run through of the algorithms and the updates. And then on top of that, the classification into MIDI mapping. Yeah. So like what I wanted to go through is like some findings during this development, is that we improved this model to be both faster and a bit more accurate and more clear for this drum cause. So this is a very applied project for this specific cause, making it faster and still keeping the accuracy at this. And to note is that it is not, I'm not going into numbers here today, but you can ask me if we take a beer afterwards, but it's not as good as like the best transformers or highly trained deep learning models out there today, but it's very fast and interpretable, and you can do more with it in the end if you want, in a creative process. So yeah, it opened up to other product features for Excellent Audio and what to work on to adapt to other types of sounds. If you want to beatbox something in, you can do this and maybe get the MIDI in, and you can do a creative workflow in that case, and it goes quite fast, is what we've seen. And you can also increase the amount of templates you want if you want to add on more instruments, and you don't have to retrain a big deep learning model in this case. And also some real-time capabilities. We saw that we can run it really fast, although that comes up to other things, is like how do you find an onset in real time and stuff like that. Right now it's a drag and drop feature. Yes. But beyond music then, why NMF is useful and why I wanted to try if we could make this work is that this has some real value in other industries as well. It's an interpretable signal and matrix decomposition, since we have signals into matrices and basically images, and we can do stuff with that. We can divide this up into templates and where it hits and where the weights are, basically. So it's both in like healthcare, I mean, it depends on the situation here, but EEG and MRI component analysis and some sensor data and anomaly detection in different industries, and also recommendation systems have been widely used with NMF through the years, having these big matrices with a lot of zeros and non-negative numbers, and some data segmentation and pattern discovery as well. So yeah, many useful things for this, and in this case a very niche project to transcribe drums into audio. Yeah, that was a quick rundown for me. Thank you very much.